Hi, so in this video we're just going to very briefly introduce sequences and series. So what is a sequence? A sequence is just a set of numbers in any given order. Each of the numbers in a sequence is called a term. So this is the first term, second term, third term, fourth term. You can write it generally using this, where you have U subscript 1 means the first term, U subscript 2 is the second term, and so on. And you can have the general term is given by this, and we say the nth term. So that's the term when n is a number, and we can then specify n equals 10 or n equals 100 or whatever. So in the sequence above, the second term is 4 and the third term is 6. Okay, so arithmetic sequence, you'll do more work on this, so just briefly introducing it. We have a sequence like this where we have a common difference of 4. So between 5 and 9 you've got 4, between 9 and 13 you've got 4, between 13 and 7 you've got 4. And you can write the nth term, the general term, using this formula here, where you use the common difference, n is the term you're looking at, and then you have to work out what adjustment is needed to get you to your first term. So if n is 1, 4 times 1 would be 4, but I want 5, so I add 1, and I can just check it with another one. Let's check it with 13. So n, because it's the third term, is 3, so 4 times 3 is 12, add 1 gets me to 13. So you can see we can generate all our sequence using that formula. No, not all sequences have common difference. In this sequence 1, 4, 9, 16, we have square numbers. We also have, later on you'll do a geometric sequences which have a common ratio, so you multiply each term by a set number. You just need to know some of this terminology. Sorry, that's my phone. An infinite sequence is one which goes on forever, so there's no end to it. And a finite sequence has a certain number of terms and comes to an end. Something called a convergent sequence, that's when the nth term gets closer and closer to a number as n increases, and this number is known as the limit. So it gets down, so basically that each term as n gets bigger, it's closer to one particular number. It might be 0, but could be anything, could be 4, could be anything. A divergent sequence, it does not converge to a limit, so it just keeps, normally they keep expanding and get bigger and bigger and bigger. Okay, so when we sum a sequence, that means we add all the terms together, we get what's called a series, and we can show you this using a Greek letter sigma, and that's this thing here. And so when we write this, what we're saying is we wish to sum all the terms from the first term when r equals 1 to the nth term when r equals n. And you could have 3, and that would mean we will want u1 plus u2 plus u3. And so this just tells us where we start our sum and where we finish our sum. And this can be something else. This could be, you know, +4 in there or some other thing. I shall do another video on answering questions using sigma notation later. Okay. And then I just wanted to remind you of some other sequences that you might have come across before. Triangular numbers, so it's just you make up the dots to make a triangle, and they come out like that. Fibonacci's numbers, where you add the last 2 numbers to get the next term. And something called Pascal's triangle, which we use in quite a few things later on in your maths. And basically, if you look here, we get the term between the terms before by adding them together. So that's 2 plus 1 is 3. Imagine there's a 0 next to here, so this is 1 and 0, and here we get 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 would give you 4, and so on, and it gets bigger as it goes down. Okay, I hope that helps. There'll be other sequences and series videos for the C1 module. Okay, bye.